Well, like I said, if you did good on the last quiz, which is what you did, you're not going to retake this. This is all retake. Yeah, just wait till the last page. Okay, so for A, I'm looking at this function here, right? Actually, we don't know if it's a function. It's a polynomial. And I need to state the lead coefficient. It's the first coefficient of the highest degree, so it's -3, right? Speaking of degree, it's the highest degree, which is 2. And what do we call a what do we call a second degree polynomial? Quadratic. Yes, I did give you a little sheet of paper for that.
Remember, this is the review that you got yesterday?
Yeah. Do you need one? Do you need help getting it out? Because I'll go in your bag and help you get it out if you need it.
Yeah, he needs you to open his bag for him.
All right, so I need to find the P of 5. Let's see. P. Boy, that's looking mighty hopeful.
I don't need this page.
So, wherever I see an X, I'm going to put in parentheses equals -3 parentheses squared plus 14 parentheses plus 9. And I'm plugging in -5, right?
Oh, I did need that page.
Boy, I could call you something, but we're recording. -5, -5, and then I would have to like call your parents and apologize for calling you something I shouldn't have called you. Okay, so I got to plug all that into my handy dandy calculator, exactly the way it is. Let's see, -3, -5 squared plus 14.
One.
I have like 2 extra ones.
Can I have one of those?
You're gonna have to pay me. It's like $25. You got $25?
Yeah, I do.
Plus 9. -136. Okay. Then we want to sketch this graph. What shape is this? Yep. Well, it's a polynomial. It's second degree, so what kind of shape am I going to have here? A parabola, right? Okay. -3. In fact, it's a parabola. It's going to open downwards. -3 x squared. Did you throw something at me? What?
In the garbage.
Did you actually make it in the garbage?
I did.
Wow.
I
Thomas,
don't need this. You want this side of the.
I don't want any side. This is for your purpose. Oh, actually, I do because it's going to be on your homework check tomorrow. 14x plus 9.
Wait, this one is?
Oh, that's the one you ripped.
Yeah.
I don't need that. I don't know. Graph it. I have this zoomed in. My window is zoomed out. I have my Y max at 50. So if you want to see the whole thing, which you're going to because you need to find the range, open up your Y max to 50 or something. So it's a parabola looking like that. I'm going to sketch this. Opens downward. Something like this. Okay, that looks pretty good, huh? What's my domain for all parabolas in this course? Good. Negative infinity, positive infinity. If you take advanced algebra, you're going to have sideways parabolas, so keep in mind they can change.
Just don't take that class.
What class is that?
Advanced algebra. It's an elective course for your
Oh,
fourth
I
year.
didn't put that one down.
By the way, did anybody take? I'm gonna pause it here. Did anybody? All right. So the range. I need my highest y value, which is going to be this is going to be my highest y value, right? So I need my vertex here, my x comma y, because that y is my highest y value for my range. So I need to compute that. Second trace, my max, enter. Now, if you didn't open up your, zoom out with your window, you're going to have a hard time with this because you need to see that vertex. So left bound, enter, right bound, enter, hit enter again. And my vertex is 2.3, comma, 25.3. Okay, so my highest y value is what? Now this is my y here. Highest y value, 25.3. Highest is always on the right, includes that point. My lowest y value, good. Good. All right, end behavior. Um, as let's see, as my x goes to negative infinity, or in other words, as x goes to the left. So as x goes to the left, what's happening to my y? It's going down, right, to negative infinity. As my x goes to positive infinity, or as my x goes to the right, my y also goes to negative infinity. Okay, so for those people who are not going to be in math next year, or for those people who are going to be in math next year, there's a couple of things in algebra that you need to get down. One of them's factoring, and the second one is this concept here, all of this concept. Graph a polynomial, be able to graph it, even if you're doing it in a calculator. Know the type and the terms and function notation. End behavior is really important. Okay. Domain and range is always important. So if you don't take a whole lot of algebra or get anything out of algebra, get this concept now and get factoring down because you're going to need it in life. All right. Any questions? Speaking of factoring, um, so everybody needs to take this tomorrow's quiz. This is new stuff. Factoring, we're just going to use our flow charts, which everybody has, right? Everybody has their flow charts. Do I need to make more?
Wait, so is it just this page that if you pass the last section?
Yeah, I don't know what every student got on
Oh,
their.
then I didn't need this. I just needed the back page. I was like,
Yeah, you have to look up your grade on Skyward and see what you got. Yeah. But everybody needs these two. Well, you want to do more than just pass,
Sorry.
right? Want to do your best.
I got 8
Fantastic.
in 1C.
Fantastic. All right, factoring. First thing, can you factor out any common terms?
Nope.
Nope. What type of polynomial do I have? Do I have two terms?
Binomial.
Why, yes, I do. I have a binomial. It's two terms. Good. Is it a difference of squares, sum of cubes, or a difference of cubes? Well, I don't know. Luckily, you got these little handy dandy charts I gave you, right?
Yep.
So I'm going to look for 216 here. And I'm going to look under squares and cubes. Going to look for 216. Nope. Look under cubes. And yes, there's 216. It's a perfect cube.
216.
And I look over to see what the cube is. It's 6 cubed. So I'm going to rewrite this as x cubed plus 6 cubed. Okay, so now I got a sum of cubes, right? So I'm going to use this form right here, this factored form, where I have a sum of cubes. I'm going to factor it to this. In fact, I'm going to write that down right here. Let's see, a cubed plus b cubed equals a plus b, a squared minus a times b plus b squared. All right, so I got to make this into that. So I need an a and I need a b. So my a is the base x, and my b is the base 6. So I'm just going to plug it into my factors here, right? A plus b. A, which is x, plus b, which is 6. And I have a squared, so x squared, minus a times b, which is 6, plus b, which is 6, squared. Now I just got to simplify it. So I have x plus 6, x squared, minus, I'm going to put the 6 in front of the x, 6x, and 6 squared. See, 6 squared, 36. There's my answer. Questions? Okay. 6a. Can I factor out any common terms? Yes. Well, I got 3 x's here and I got an x there, so I know I can take out an x. Can I take out anything with the numbers? 6. 6 is a factor of 54. Okay, 6x cubed divided by 6x, x squared.
X squared minus
54 divided by 6 is 9. And the x is canceled. Okay, let's look at x squared minus 9. Is 9 a perfect square? Well, let's see. 9 perfect square. Yes, it is. It's 3 squared. So I'm going to rewrite this. 6x, x squared minus 3 squared. Let's see. My a is the base x. My b is the base 3. So I have 6x. Let's see, I got a, let me make sure here. Difference of square. A plus b, a minus b. So x plus 3, x minus 3. And I'm done. Questions? All right, number 7. Can I factor out any common terms? Nope. 3 is not a factor of 5, so that's not going to work. What type of polynomial do I have? I don't have 2 terms. Don't have 3 terms. I have 4 terms. I'm going to factor by grouping. Group the first 2 terms and the last 2 terms. Group the first 2 terms and the last 2 terms. Factor out the greatest common factor of each and finish factoring. Okay. What could I take out of the first quantity? A 3. How many x's can I take out?
2.
3x cubed divided by 3x squared. X to the first. 12 divided by 3 is 4. The x squares cancel. Okay, what about the second quantity? I can take out
5.
a positive 5, right? I get x plus 20 divided by 5 is 4. And the whole purpose was to get the same quantity, right? So that you could actually do the same thing, take out the x plus 4, and I'm left with 3x squared plus 5. And give a quick look over to make sure this doesn't factor because it is a quadratic. And this does not. It's not a difference of squares or anything I can do. And then the last thing we did, inverse functions, right? And this will get us up to date here. How do I find inverse functions? You guys remember? Yeah, switch the x and the y. So if I don't have a y there, if I have function notation, highly suggest putting a y there. Okay. So I'm going to switch the x and the y. So I have x equals 4y minus 9. Then I'm going to solve for y. So I'm going to add 9 to both sides. Don't combine those. I have x plus 9 equals 4y. And then get rid of that coefficient 4, right? Divide by 4. So my inverse, my y inverse, or my f inverse of x, same thing, right? Is x plus 9 divided by 4. Okay.
So wait, what? I'm sorry, sir.
This is on your test too. These questions are going to be on your test. With inverse functions, what happens to the domain and range? Switch, right? My domain becomes my range becomes my domain. So they switch. Sometimes, always, or never. A function and its inverse are the same. Sometimes, right? Sometimes. Do you guys remember when we had uh, the f of x equals, say, 4 over x. Yeah, the inverse was exactly the same. F inverse of x also equaled 4 over x. So sometimes it does happen. 3, can you have a function whose inverse is not a function?
No.
Yeah.
If you want.
I just took a 50-50 guess.
You're just guessing?
Yeah.
Um, you certainly can have a function whose inverse is not a function. Don't forget, it reflects over that line.
Hans is mean.
Let me do an example. What if I had a parabola? Okay, that's a function, right?
Because it passes the vertical test line.
Yep, it passes my vertical test line. And then, you guys remember what line it reflects? In fact, that's one of the questions here. The y equals x line, right? If I reflected that about the line, the y equals x line, I would have like a sideways parabola, wouldn't I? And that's not a function.
Nope.
What was the new test we had for determining that? Horizontal line test, right? If the original passes the horizontal line test, then the inverse is a function. Questions, comments, concerns?
So homework checks tomorrow, and then I put